Hi, Joe Cerrone,
Al Rosen.
and we're going to talk about dimensioning mechanical drawings. And so as we look at the way the textbook is laid out, what we like about this book is that it goes into some of the standards for dimensioning. And so chapter 5 is on dimensioning mechanical drawings, and then chapter 6 is on dimensioning architectural drawings. And what we're going to do is we're going to work with this ASME Y 14.5 drafting standard. And that's what all of your companies are doing now. They all have these standards, and if the parts don't meet those standards, then they can reject them. And as we look at the objectives for this, what we're looking at is being able to look at size dimensions and location dimensions, and then just the general terminology so that when you talk with somebody, you speak with the correct words. We'll apply these standards. We'll look at associating dimensioning with these do's and don'ts for mechanical drawings, how dimensions are determined, tolerancing, fits, more standards, drafting roles, AutoCAD dimensioning toolbar. They go through everything like you've never seen AutoCAD. And so some of this may be review for those of you who've gone through the basic AutoCAD. But as we go through it, we just want to make sure that we cover our bases. And so as we look at this, we can take a look at these mechanical parts here, like this tool slide. And then here's how we would lay out the views for those. And so traditional drafting has always been front view, right side view, top view. And then we typically throw isometrics in there, but most people draw with a computer now. And so as we draw with the computer, we're going to adopt these different standards. And so what the author likes to do is they like to just take these sketches and put them together. And they talk about the necessity of making dimensions. And what is it that you need to do? When I was a design engineer for Signode, a lot of times you would just over dimension things. You would put on everything they needed to dimension it. And if you don't, you'll get called down to the shop floor because the guys can't make it. And it's not their fault if the dimension isn't on there. If they go and they make something without a dimension on there, and you want those guys to help you. And so you want to be really cooperative when you work with the shop guys. But they're there to work together with you. And as we go through, we want to go through and be able to dimension our parts the proper way. Things like how many decimal places of accuracy and locations that you're dimensioning to are very important. And so oftentimes they'll use like a datum to be able to set a theoretical perfect edge or a 0 point or a distance from one feature to another. As we look at dimensioning, what we're looking at is we're just looking at being able to manufacture that part. We want the overall length and height of the dimension. Those are size dimensions. Same thing with this hole diameter. Holes are dimensioned in diameter. You don't want to dimension a circle like this that would be a hole with a radial value because we don't want the guys in the shop to do the calculations. They don't want to take 0.375 times 2. We want them to just give them the actual value. And then as we go into location dimensions, we want to locate that from a specific place. And so this is dimensioning it from this left side edge and from this top edge. As we look at the dimensioning terminology with AutoCAD, this is called a leader. AutoCAD calls it a multi-leader now. And just like dimensions, we have multi-leader styles. And we can set those multi-leader styles up. And as we look at these, what we'll do is we'll create the multi-leader. And a lot of times when I create these multi-leaders, I'll use the wingdings, or no, they actually have a GD and T symbols area. And so if I look at this, let's see if I have it. There we go, right here. And then if we look at this dimension, hopefully my computer will come back to life. It's not. Let's try model space. Let's go to the top view. I'm at my office computer. My laptop is faster. And it's on a locked layer. So let me unlock that. And you'll notice when they're on locked layers, they're kind of faded. That's to kind of give you a visual cue. And so this is a multi-leader, and if I double click on that, I can go and see the text. Things like this, okay, this is a diameter symbol you can get from the symbols. And so you can go and you can add symbols. It used to be you'd have to type in the control codes like %D for diameter, because there's no diameter key on the keyboard. And so the other thing that you can do is when you go into creating the text for these, you can go and create, you can use a different font. And so when we go into these character sets, this one is set for Western. Let's see if they have winged ones or the GD&T. And I'll have to go back and figure out where that is because I'm not getting the character sets that I want. I'm getting something different here. But I will figure that out, and I think we can get that established. If I were to put in some text, and then when we go to put in the text, I could go and select my font. Al, do you know where that is? Where I would find my...
Right above you.
I don't understand what do you mean
All
by
the way up on top, you see the big A, blue, right next to it, just to the left of it, left to it, up, 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 up. There you go, down, 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 down. A little bit more.
doesn't help me. You got to tell me the words for them, like under Express Tools or Text Editor helps me a little bit more.
Under Express Tools, just directly underneath it, what you just had.
Okay.
There it goes, right there.
Right. There we go. Thank you very much, Al. And so you can pull in like a GD&T font. And I'm not sure why I'm not able to see mine now, but let's just say I wanted to put in a symbol like this. And so I can go here, and then I can go and I can add those symbols from the character map setting. I'm going to get it kind of hung up on this, and it's starting to drag, but we'll come back to that. You can get most of these in here just from our regular symbols, but take a look. You should have a GD&T symbols area. All right. Returning, let's go back to where I was in my lecture. There we are. So we can pull these from the character maps, and you can copy and paste them into the text. And as we go through and we work with some of our terminology, leaders are called multi-leaders. When we work with the CAD system, you can create a leader style. And so if I come back here to my drawing and we look at the annotate tab, right here on multi-leader, it used to be all under dimension styles, but you can go and create these different styles for multi-leaders. And they work very much like the styles that we had for dimensioning. They allow you to have arrowheads, different symbols and things like that that will terminate that. They also allow you to have things like different types of number of clicks that you'll have for leader points. They allow you to have these formatted for straight lines, or I like to use splines when I do architectural. It's more artsy. And when we get into the content, we'll use these different text styles and text heights. If I wanted to tweak this and fix it, I could say 0.125. This one is not per ASME Y14.2 standard. It's a little too big. Is anybody going to notice the text that's slightly off? Probably not. But they will notice if you are missing a dimension. All right. Some guidelines for dimensioning. As we look at dimensioning, you want to avoid dimensioning to hidden lines. You want to basically dimension to features that are visible. And so they do a pretty good job here of telling you do's and don'ts. And so we can kind of look at the pictures here. And it's, to me, I'm a picture person where I can just go, oh, that's what I don't want to do. You don't want to cross over dimensions. Okay, dimensions should be placed evenly outside of the object. You want to avoid placing dimensions on the object when possible. Okay, avoid them. It's okay to have poorly placed dimensions as long as you have them. It's better than, excuse me, not having any. So this is a good example of how to dimension. It should be neat and accurate. You should avoid things like dimensioning to hidden lines and center lines, and lay them out according to these standards. Here's our ASMEY 14.2 textbook on dimensioning. Dimension sizing and spacing. They have a lot of really specific things if you get into engineering graphics. I used to teach the engineering graphics lab sections up at Northern Illinois University. I would teach the courses and they would pay my tuition. It was a great deal. I was a graduate student for them, and I put in the CAD labs back in the day when I was in NIU. And you would have to go through and measure the size of the arrows with a pencil, and you'd have to do all of these things the old-fashioned way. It's a lot of work, but you can set these standards up in your dimension styles. And so as we look at things like dimension text heights and things like that, you know, here they call it 0.12, 0.125 is typically 1/8 of an inch printed on the paper text height. And that's where it gets a little tricky when you draw things and you have to calculate the dimension scale. And we'll talk about that as we go through it. Different things like unidirectional dimensioning is shown as well. And aligned dimensions. Okay, these are other things that we can set up in our dimension styles. But you can see, you know, some of these drawings are easier to read than others. When the dimension is unidirectional or it's horizontal like this, I find it a little easier to read. I don't have to turn my head or interpret that. Just small things here. Diameters, okay, when you drill holes, you want to use diameter dimensions. When you have things like fillets and rounds, you use radial dimensions. You want to put center marks to show the center locations of those dimensions. When you use center marks, you can also go through and you can use the center mark tool, which is right here. Put your center marks on a center line layer. So as you start to create these drawings, you want to make them correct. I'm just going to check the room real quick to make sure I didn't miss anybody. Looks like I'm okay. So set the dimension layer, and then if you use a center mark, if you click on an arc, you'll get a center mark for that. Now they've upgraded this center mark tool, and so by doing so, the center mark gets really big, and you can tweak that by hitting the arrows and pulling the arrows in. And so typically when you dimension, the bigger the hole, the bigger the center line. The smaller the hole, the center line. It sounds simple, and it is. The other center line tool doesn't want to cooperate. There we go. The other center line tool is this one right here, and it's for putting a center line between two lines. So if this was a hole feature, which it's not, we could use it by tagging the top line and the bottom line, and then it'll create that center line right through the middle. Now you'll notice that it doesn't show well, there's a line underneath it or something. I'm not sure what that is, but some of them are caused by what's called dim scale, or excuse me, LT scale. And if you tweak the LT scale, it'll oftentimes fix the geometry. In this case, that's not the case. In this case, it's caused by paper space, model space issues. And so if I double click, and the reason it didn't work is because it's in paper space. If I'm in model space, there we go. And if I grab a top view and I do that again, you'll get the center line with the correct geometry. In other words, long dash, short dash, long dash. Like I was saying, when we drew with a pencil, you would actually measure how much space was between them. When we go to paper space, the problem that I often have is this thing called PSLT scale. PSLT scale. Write that down. And if you set it to 0 and then you regenerate the screen, it usually fixes them. And apparently it didn't work on it. This one. set it back to 1. We'll come back to that. AutoCAD is a little glitchy at times with it. There, it is working. It's my graphics. All right. So again, how to dimension objects, diameter symbols. You have to insert the diameter symbol. Now, if you put a dimension in and it doesn't have a diameter symbol like this, because it's dimensioning to a rectangular part, what you want to do is, let's see here. Let's grab something here. And I don't have a diameter on it, but let's say I hit a rectangle. And if I wanted to put in a diameter dimension, what I would do is I would dimension to the endpoints. I would locate the dimension, and then I would double click on that dimension, bring the cursor to the front of it, and then I would go to the symbol. Now, you want to make sure that you don't get rid of the text because it's associative. In other words, if I stretch this, it's going to change these numbers. And this is super duper high precision. This would cost a fortune to make it this accurate. But what I would do is I would go to the symbols and I would put in the diameter symbol like that. Then I can click off of it. The other thing I would do is I can click on a dimension. I can right mouse click and I can dial down the precision, because anything more than 3 decimal places gets very expensive. So aerospace will work 4 dimensions. And so if you talk to the guys at Woodward who make parts for helicopters and airplanes, they're right over here on Howard Street in Skokie, they'll tell you that they hold 0.0005, and it's very, very fine. A human hair or a piece of paper is about 0.003 thick, or 3 thousandths, tenths, hundredths, thousandths. So that's how you would insert a symbol into an existing dimension. You don't want to explode the dimension or edit it. What you want to do is keep the associativity and just add the symbol. How to dimension angles, lines of symmetry, basically meaning that whatever's on the left is equal to whatever is on the right. Ordinal dimension, this is what I was talking about in our other example, how to create that plate dimension. The user coordinate system needs to be located at the 0 point to put those dimensions in. So if I go back to my drawing here and I want to add some dimensions to it, always work in model space. I mean, you can work it within a viewport by clicking in it like that, but we prefer you to work in model space at this time. I'll probably take that back, or Sebastian will, when you go into the advanced class. But if I want to add, let's say I wanted to add a dimension here, I put another hole in this plate. And we won't worry about the layer on that. And we'll just go and add a center mark so we can find it. To add an ordinal dimension, what I would do is I would go to my dimensions and I would say ordinal. And then I would say I want an ordinal dimension from right here. And it's actually good. It's 1.22, okay? Meaning it's an inch. Actually, this is not a good dimension, so something is goofy on it. It should be 1 inch and some change on it. And I'm not sure what's in my dimension style. I opened up a different dimensional drawing, so I'll have to come back to that. But I'm pretty sure it'll work if I was using a different drawing. And so if I were to go here, I think it's my UCS. And so I'll say UCS, and then I'm going to go down arrow, and I'm going to put my origin. I'm going to have to just say O for origin because I can't find it. UCS, origin, and I'll put the UCS origin right here. Bam. Now I should be able to get an ordinal dimension. There it goes, 1.8. And that looks right. 1 inch, 4 inches. Yeah, that's right. And so put them on the right layers. And you're good to go. All right, so that's an example of an ordinal dimension. And then as we look at things like machining operations, and I'm good. I've been in the machine shop since I was 13. That's what happens when you're not good at English in high school, at least back in the 80s when I was in school. it worked out really quite well for me because I think I'm pretty happy doing this kind of work. As you go through and you work with things, you want to start to look at what a counter bore is and a countersink, because people, if you do work with it, they will expect you to kind of know those things. Counter bore is a relief for something like a washer, and a countersink is a chamfered. So you have a slotted or for a machine screw that would fit, or a wood screw that would fit. So a lot of your fasteners will have these standardized reliefs or angular measurements. And so as you go through, pick up on that and we'll teach you how that works. And that's how to put in an ordinal dimension. They're doing the same thing. They're showing you how to put in the diameter dimension. And then here's some more do's and don'ts for dimensioning of mechanical drawing. And we learn by doing, so as we go through and we work on these projects, that's what we want to do. As we look at, the role of a draftsperson, you're going to be the guy who's going to be setting the number of decimal places. You're going to be determining which dimensions are important. And so it's a thinking person's job as you get into engineering work or design and drafting work. And that's why it pays at the level that it does. The guys that are out there doing engineering work, typically pulling down at least $50,000. I shouldn't say at least, but that's kind of where you're at, And I was working in the 90s, we were making pretty close to that at that time. So I would think it's pretty close to that now. Dimensioning, checking dimensioning. It's always a good idea to have somebody else take a look at your drawings, especially if they understand how the parts are manufactured. Okay, that's the end of part 1. I'm going to end this recording and then we can make another one if we need to for part 2.